Okay, so next unit we're talking about is the periodic table of elements. So we're going to start to get to know the periodic table. You're going to be using it for the entire year. So we'll be coming back to it over and over and over again. So we're going to start kind of just learning about how and why the periodic table is in the order that it's in. Dmitry Mendeleev was a Russian chemist who was the first one to organize the periodic table, and he organized them based on their properties and put them in order of increasing atomic mass. So at the time, there were several empty places on the periodic table, but because of the way he started to organize them, he was able to predict what those properties of the elements would be, even though they hadn't even discovered them yet. Here is a picture of Mendeleev's original table. So you can see it looks somewhat similar to ours, but there's a lot of differences. So these will end up being kind of rearranged as they start to learn more about the elements. Henry Moseley was an English scientist, and he developed the periodic table that we know now, so the modern periodic table. So he kind of built upon Mendeleev's. And he put the elements in order of increasing atomic number. And other changes that he did to the periodic table was that he added the noble gases. He added the rare earth elements called the lanthanides, and also the actinide elements, which are radioactive elements. So, here at the top we see a periodic table. Whenever you have a vertical column, and you're going to hear us refer to groups a lot. So it's important to know the difference between a group and a period. So a group is a column, okay? So important to remember that. So column 1, column 2, and so on. There's a total of 20 different columns, and each column or each group has similar properties, okay? So for example, column 17 here, those are the halogens, and we'll talk about those properties at a later time, but so fluorine, chlorine, bromine, iodine, all of them have similar properties because they're in the same group. Okay, and the rows are what are called periods, and there are 7 periods, and each of them occupy a higher energy level. Okay, so the periodic table has metals, nonmetals, and metalloids. And you can see the division between the metals and the nonmetal is divided by that stair-step line near that blue area where it says metalloids. So everything on this side of the periodic table is all metals. So they have properties of a metal, such as luster, means they're kind of shiny, malleable, which means that they can be bent. Ductile means they can be pulled into wires. They are good conductors, so this is why, like the wires in your house, when you flip on a light, those wires themselves are made of certain types of metal. And most metals are solids. On the right side of the stair-step line, we have the nonmetals. And these are brittle. These are what would be the insulators. So again, the wires in your house, they're coated usually with like a colored plastic. Those are typically made up of non-metal elements. And this is because they won't conduct electricity. If you didn't have those insulators, then every time you turn on a light switch, your wall would catch on fire because that electricity would be, there would be nothing stopping that electricity from going out into your wall. The difference between metals and nonmetals, one of them is that nonmetals can be solids, liquids, or gases. Okay, and then somewhere right here in the middle, we have our metalloids. Now these are unique in that they have properties of both a nonmetal and a metal. So they tend to be poor conductors, but then they can have other properties that make them similar to a metal. So it just depends on which metalloid you're talking about. Okay, we're going to be talking a lot about valence electrons. And a valence electron is the electrons in the outermost energy level of an atom. And we haven't talked too much yet about the structure of an atom. but you've probably seen it in past years in science. So you have protons and neutrons swirling around the center, or not swirling around, they're in the center of the atom, and then swirling around the outside are the electrons. And in the very outside rings, so you think about like rings of Saturn, are what are called the valence electrons. And this is what helps electrons bond to other atoms. Okay, so in general, the number of valence electrons is whatever group they're in. Okay, so here again is kind of a picture of our valence electrons. Here, group 1, all of those tend to have 1 valence electron. Those in group 2 have 2 valence electrons. So you can kind of see where this is going. For the most part, these transition metals here, it depends on so we kind of ignore those for now. We'll get to those later in the year. And then so on. So these have 3 valence electrons, 4, 5, 6, 7, and 8 valence electrons. So as you get closer towards that 8, you're adding more and more, which means they've got more electrons in their outer ring. Okay, so there are other groups of the periodic table that you will need to know. Even though hydrogen is over here, he is not actually an alkali metal. So you can see here, these are the alkali metals. Okay, and then you have the alkali earth metals here in blue. All these here in the middle, that big group that we're not ignoring them, but we'll just get to them later. Those are what are called transition metals. And then we've got, these are referred to as poor metals, and we got some of the metalloids. They don't have the best metal properties, so they're kind of, shunned by the other metals. Okay, and then we have our nonmetals here, and then we have noble gases.